Before we begin this session, I want to clarify one important academic point related to this presentation. You will notice that this presentation contains several images. All these images are AI generated images. These images are used only for teaching and learning purposes. They help us imagine what is happening inside the computer during the startup. Many processes inside computer system cannot be seen with other eyes. We cannot see electricity flowing, the processor waking up, or memory being checked. Images helps us to visualize these invisible processes. I am not claiming ownership of any of these images. They are not taken from real products, company manuals, or copyrighted sources. They are used purely to improve understanding, clarity, and student engagement. With that clarification, let us now start the topic. Let us begin with a very simple thought. When a computer is switched off, it is completely inactive. It is not running slowly. It is not waiting in the background. It is fully powered off. There is no operating system running. There is no program in the memory. The processor is not even executing either of the instructions. At this moment, the computer is just a box of electronic parts. Now think about what happens next. You press the power button. Within few seconds, the screen lights up. The keyboard becomes active. The operating system loads. And this change looks very fast to us. But internally, it happens step by step. And this complete step by step process from power off to a ready system is called the boot process. Every computer must follow this process. It does not matter whether the computer is new or old. It does not matter which operating system is installed. If the process does not complete correctly, the operating system can never start. So before learning what an operating system does, we must understand how it starts. Now let us focus on very first action, pressing the power button. This action looks pretty simple, but its role is very, very important. At the moment you press the power button, the computer still does not show who the user is, which file exists, which operating system is installed. The power button does not directly start Windows or Linux. Its only job is to allow electrical signal to enter the system. One can think of like opening the main gate of our department. Opening the gate does not start the classes. It only allows students and teachers to enter. In the same way, pressing the power button only allows the computer to begin its internal preparation. And this step clearly shows that hardware activity starts before the software activity. So as soon as the power enters the computer, the power supply unit becomes active. The power supply unit is responsible for controlling electricity. It checks whether the voltage is correct, whether the power is stable, whether it is safe for the components. If power is not safe, the system immediately stops. And this is done to protect the motherboard, processor, memory, even the storage devices. And this step is very, very important. If unsafe power reaches the system, it can permanently damage the hardware. We can relate this to programming for a while. Before using any data in a program, we first validate it. And if the data is wrong, we do not continue the execution. In the same way, if power conditions are wrong, the computer does not move to the next step. And this step teaches us an important principle. Checking always comes before the execution. Now, we reach a very important stage. And the first program of the computer starts running. And this program, generally known as BIOS, BIOS, or UEFI. BIOS means Basic Input Output System, and UEFI means Unified Extensible Firmware Interface. This program is not stored on the hard disk or even SSD. It is stored on a special chip, available on the motherboard. And that is why BIOS works even when no operating system is installed. BIOS has very clear responsibilities. First, it wakes up the processor, then it activates the basic hardware components. It checks which devices are connected to the system. One can think of BIOS as the person who opens the office every morning. They unlock the doors, switch on the lights, check whether everything is ready. Only after the preparation or only after this preparation, the actual work can begin. In the same way, only after BIOS finishes its work, the operating system can load. Now, before loading the operating system, the computer checks its own condition. And this checking process is called as post power on self test. It is like a basic health check for the system. It checks whether RAM memory is available, whether the processor is responding, whether the input devices like keyboard and mouse are detected, whether storage devices are connected. If any important component is missing or faulty, the system stops immediately. And why this is done? Because loading an operating system on faulty hardware will lead to failure later. And this is similar to checking whether all required equipments are available before starting the lab session. Post, that is power on self test, ensures that the system is ready for the next stage. And if, let us say, post finds a problem, the system reports it. Often these reports are shown on the screen. For example, RAM not detected, storage device not found, processor error. These messages clearly tells us which part has the problem. These errors happen before the operating system loads. And that is why reinstalling the operating system even cannot fix these kind of problems. This particular slide will help all of us to clearly understand the difference between hardware problem and software problems. It also helps in real troubleshooting too. Now consider a situation where, let us say, display is not working. In such cases, the system cannot show the error message on the screen. So how does the computer communicate such a problem? So it makes use of sound. The sound produces beep sounds called as beep codes. Different beep patterns indicate different hardware problems. And this method is very, very useful when no visual output is available. It shows that computer always try to communicate problems in some way. So before any operating system runs, before any program executes, before any user interaction begins, the computer prepares itself carefully. This preparation process is called as boot process. And understanding this process helps each one of us to understand how computers start, why systems fail, and where actually the problem began. And this knowledge forms the foundation of studying the operating system concepts.